So you guys, as I explained the sum to infinity, for this specific example, we found out that the sum to infinity is 2 over 3, right? Another way to say say that the sum to infinity of this specific example is 2 over 3. It is to say that the series. Another way to say that the sum to infinity for this specific example is 2 over 3 to say that the series converges to 2 over 3. That's an English way of saying it. You are essentially saying that the higher the value of n, or as increase the value of n, it's going to get to a point where the value won't change the answer you get. It will still be like the same value. In this case, 2 over 3, right? So that is you basically saying the series converges to 2 over 3. It stops there, regardless of the value of n, or the higher you go for the value of n as it goes to infinity. I'm just repeating the same thing just so you guys understand. It's called tautology. Sharp. So now we say that it converges. There's some series that do not converge. That is, the higher the value of n, you're not going to get to the same sort of answer. There are those types of geometric series. Now, for the series which converge, the value of r will always be between -1 and 1. That is, if you come across a geometric series whose constant ratio is a number between -1 and 1, it's not -1 or 1, it is somewhere between -1 and 1. I'll draw you a number line just so you guys can see. 0, 1, 2, -1, -2. Now, the condition for convergence, like for series to converge, that is to approach a certain number as n goes to infinity, the value has to be between, the value of r has to be between a number, the value of r has to be a number between -1 and 1. So if it's 0.5, you know, you don't even have to test, you know that your series converges. That is, it's got a limit, basically. 2 over 3 in this case. If it's minus 0.5, you know that it converges as well. If it's minus 0.9, you know it converges. Okay. If it's 1, it doesn't converge. If it's -1, it doesn't converge. If it's any number that is above 1, it does not converge. If it's any number that is below -1, it does not converge. This is what we call the condition for convergence. Condition for convergence. Okay. Convergence. Convergence. Okay. It's got a limit. Okay. So yeah, the opposite for converge is diverge. So diverge. So a series is diverges when the ratio is not between or doesn't fall within this bound. A series diverges if the ratio does not fall within this bound or this restriction. Another way to put it, we say a series diverges if the sum to infinity doesn't approach a specific number or value. I'm over elaborating just so that everybody understands. I'm listening to myself. Are we all happy with convergence and divergence? Divergence just means it doesn't converge. Are we all good?